Good morning. I'm Roberto Bruschi. I'm from University of Genoa and CNIT. I'm serving in CNIT as coordinator of the Six Green project, one of the SNS projects. What we are doing and what is the main focus of this presentation? We are dealing with energy efficiency and environmental sustainability, starting from the 5G to collect some new hints, to evolve the 5G and to arrive to the 6G within the project. And we are starting from the SBA, from the core of the network. Now, in this presentation, I would like to, to give you a vertical perspective on some of the problems that we are facing regarding environmental sustainability and mobile networks, because that's a very complex problem. We know that today we have new infrastructure based on the edge cloud continuum. We have many stakeholders that are part of that can interact with the platform. This is true in 5G and 6G. It will be even more true. And that might change somehow the workload and then the energy consumption that the 5 or 6G system is resulting on the infrastructure. So one of the problems that we have is that if we think to the environmental sustainability, to the part of the environmental sustainability that springs from the use of mobile networks, we can see from this complex picture on the right that energy consumption happens only in one of the layers of our architecture. That is the infrastructure layer, okay? What is consuming energy are physical elements. They could be radio units, base station, servers, etc., that are composing the continuum. On top of that, we have at least two other layers. We have the layer of the 5G system, of the network platform, we can say, that is doing what? From the 5G, we are able to produce a network of networks. So we are able to give slices to applications. And the application might request these slices in order to provide certain connectivity requirements from a certain physical position to some part of the edge system or the cloud system. It depends on the latency budget that we could have. We are lucky because some of the, not all, but some of the hardware architecture that we are using can support power management. At least some server might be shut down. We can reduce the speed if this might be convenient of CPUs, of GPUs, or we can use, that is the, let me say, the most interesting power management feature. We can use low power idle, for example, or we can change the power configuration of some subcomponents inside. So in such a way, what happened? We have a trade-off from the hardware level. Trade-off that change the capacity, the computing capacity, the transmission capacity of the overall system, and that can be exploited by the software workload, so from the network platform and from the vertical application. But how we can exploit this? Like in any cloud system, in any controlled system, we need some new enablers. So we need, for example, the capability to monitor, to observe what is happening in our system, in all the layers. We need to extract the energy that is consumed at the infrastructure level and to provide these metrics to the 5G or 6G platform and to the vertical players that somehow, with their decision, are changing the workload of the workload and then the energy consumption of the entire infrastructure. Then, through automated decisions, zero-touch decision, etc., we could change then what is happening. For example, we can migrate some part of the workload, some part of the platform, some part of the application in small data centers that are supplied with renewable energy sources. But we need to be efficient and transparent in migrating the workload. Otherwise, we are destroying services. And another feature, another enabler that is quite important is that the workload for any slice, for the entire platform and whatever else, it's not fixed along the day, along the week, along the month. The workload is changing, and then we need the possibility to scale and to use accelerator whenever they become efficient with that level of workload. If I'm enabling a GPU or a P4 switch just for carrying few bits per second, that switch will have, or the GPU will have more or less a fixed energy consumption, and it might become not efficient. Now, in this presentation, I would like to focus on this blue line in order to outline to you, this is a summary of the main enabler that we are studying within Hexa-X-II, but I would like to focus on the observability role. So on the what we are calling inside the project, the back pressure. The back pressure. The energy measurement, the CO2, the greenhouse gas emission that are caused by the platform and by any slices or edge compute or vertical application that are housed inside our network. One of the problems that we faced is that energy metrics in general are native only of the physical infrastructure. The physical infrastructure provider is then selling resources through the usual as a service contract. The upper levels usually have only economical agreements. They are not directly consuming energy. That's an indirect consumption. So what I mean that the energy metrics might be mapped into KPIs, into metrics that are understandable by the other players. And if the agreement, if the relationship among these players, stakeholders, is of economical nature, we should translate the energy consumption and the greenhouse gas emission into the terms of an economical contract very inspired to the as-a-service economy. That's what we are trying to do. What we are doing is to try to build analytics, let me say, that allow us to understand how the physical infrastructure is consuming and how much of the budget of energy that is consuming is due to slice A and application 2 or slice B and application 3. That's not a trivial task. Why? Because it's like a multi-tenant infrastructure. Every server is populated by many containers, virtual machines, software artifacts that belong to various tenants. And some of these artifacts are even shared. For example, it might happen that a single slice, that two slices, use the same UPF. That UPF is shared among two tenants. And then we need a way to extract which is the impact for tenant A and tenant B, for example. That's a very difficult task, and especially this observability and analytical framework should not be too invasive. Otherwise, we will fall in the problem that only the system to observe and to derive metrics will consume or will cause more carbon footprint of what we can save through the application of that. That's a quite complex problem. We started in Hexa-X-II developing some functions to be added to or we evolved some function to deal with these green metrics. We, for example, designed a prototype of an IDAF, so of an infrastructure data analytics function, and of an MDAF for collecting the metrics for the platform level. So in such a case, what we are doing, we are trying to collect any performance metrics of the various containers, of the various virtual machine, of every software instance that is somehow insisting on the various servers that we are managing. We can collect some energy metrics from some software probes that we have inside, like Scaphandra, that is able to give some energy consumption estimate depending on the use of the CPU, or some external PDU that have some energy metrics. We are collecting all these metrics and putting it into a Prometheus database, and then through an Envs, we run analytics in order to map the various containers, the various software instances with a number of metrics, for example, the packets that have been elaborated, in order to produce metrics for the platform and for the slices. This is a more complex picture of what we are doing, of the experimental setup, in which I'm going to show to you some of the results that are here in the slide. You see here, for example, that's a very simple experiment that we did some months ago by using an open source implementation of a 5G system, very simple, Open5GS, in which we started by collecting the power and the CPU consumption of every function. Try to map and to collect also information on the specific workload of every function. Now, in this period, we are using we are developing some models and some analytics that will help us to extract the energy consumption through the overall platform by the functions that are specifically dedicated to every slice, in order to build somehow a sort of level of carbon footprint and energy consumption that is ascribable to a specific tenant, to a specific vertical stakeholder that is using the system. How we want to use that? We would like to use this to translate substantially the business model that this tenant might have with the operator. Just a simple example, we would like to have into the SLA that a tenant could sign with a telco operator for a decarbonization environment. The tenant might ask the best service, for example, for a certain cap of greenhouse gas emission or energy consumption. How we can do that? We can do that through exploiting, for example, the edge cloud continuum. And for that slice, for that host, we can move part of the computation where renewable energy is present, and we can exploit this, for example. In the reality, there are many. I tried to simplify a lot the overall problem. Inside the project, where we are, let me say, the questions are more than the answer, but that's quite difficult to bring a design of a system that was not thought to be sustainable to arrive to this kind of system and to provide external stakeholder with this kind of metrics. Here you see some of the work in progress that we have. Now we achieved the first version of our observability framework. The first results that we are doing in labs are quite interesting. But again, there are a number of points that should be somehow better identified, better studied. I think that our trip to the environmental sustainability will be quite long and difficult. Okay, I just finished my presentation.